Hey guys, what's up? Welcome back to another video, and today we're going to be trying a few questions from a year 10 maths paper. So let's get straight into it. The first question is about logarithms, where we have to find the value of this using the two given values and without a calculator. So we start by separating this log a of 0.75a squared. That can just be written as log a of 0.75 plus log a of a square. Now log a of a square, we know that we can bring the 2 down. So if we bring the 2 down from the power, we get 2 log a of a. So log a of a is obviously just 1, so that we can just remove that and write 2 in its place. Now log a of 0.75, 0.75 can be rewritten as 3 over 4. Now using the property where log of a over b is equal to log a minus log b, we can rewrite this as just 0.477 minus 0.602 plus 2. Now if we put this into our calculator, we get 1.875. 1.875, which would be our answer. So we can see that we have just used this log in different bases, in a different base, unknown base, so we can still find the value of log a 0.75 square without even needing to find out what base we're working in. So with that, let's move to the next question, where we have to solve for x. Now this question, we just need to use a substitution. So we can just let u equals x squared minus 4x, and rewrite this as a quadratic. We have u squared plus 11u plus 28 equals 0. Now we can just simplify this by finding two factors which multiply to 28 and add to 11. Now that just be 7 and 4. Now here we need to see that u plus 7 is equal to 0. So u can be equal to minus 7. And u plus 4 is equal to 0. So u is equal to minus 4. Now I'll just get rid of whatever was before this. And we need to substitute back in x squared minus 4x for u. So with that, we get x squared minus 4x equals to minus 7. So we have x squared minus 4x plus 7 equals 0, another quadratic. So here we can just find two factors that multiply to 7 and add to minus 4. But seeing that there are no factors, because the only factors of 7 are 1 and 7, which do not add or subtract to give 4. So we'll have to use the quadratic formula, where we get minus 4. So 4 plus minus square root of 16 minus 4 and a, which is just 1, and 7. Now looking at this, we have 16 minus 28, which means this will give us a result in the imaginary numbers. And looking at the question, we only have to solve within x for reals. So we can just get rid of this quadratic and focus on the other one, which gives us minus 4. So substituting back x squared minus 4x is equal to minus 4. And we get x squared minus 4x plus 4 equals 0. Now here we just need to find two numbers that multiply to c, which is 4, and add to give minus 4 or b. So we can just do that with x minus 2 squared. So x will be equal to 2, and that is our only solution within the reals for x. Now let's move on to the next question, which says prove cos theta over 1 minus tan theta plus sine theta over 1 minus cotan theta is equal to sine theta plus cos theta. So the first thing you'd have to do is rewrite tan theta and cot theta in terms of sine and cos. So to do that, we know that 1 minus tan theta is just equal to 1 minus sine theta over cosine theta. Now we want to bring this over one fraction, so we could just write this as cosine theta minus sine theta over cos theta. So this will be our first part as our simplification for the denominator, but we also need to simplify the other one where we have cotangent theta. So cotangent theta is just 1 over tan theta. In other words, instead of sine theta over cos theta, we just have cos theta over sine theta. So rewriting this, we could see that this will give us sine theta minus cos theta over sine theta. So that is our part for the second. Now let's just simplify this now. So cos theta over cosine theta minus sine theta over cos theta again. We can just reverse the fraction and multiply. So we get cosine square theta over cos theta minus sine theta. And then we have plus, so reversing this again, sine square theta over sine theta minus cos theta. Let me just rewrite this because there's no space here. So for those of you who are wondering how we got this, what we did was we substituted this part into here, and we can just reverse the fractions and multiply, which gives us sine square theta over sine theta minus cos theta. Now from continuing from here, what we have to do would be to factor out a -1 from the denominator of sine theta minus cos theta so that we can get it over the same denominator. So we'd get cos square theta minus sine square theta, and we factor out the -1 and bring it to the top. So when you factor out a -1 from here, we get plus positive cos theta minus sine theta, so which is essentially the denominator here. So the fraction here would just be the last one. So cosine square theta minus sine square theta over cos theta minus sine theta. Now here we can see that we have a difference of squares here, where it will just be a square. So let me just get rid of this at the top so you guys can see. So we'll just have cosine square theta minus sine square theta, where cosine theta is equal to a and sine square theta is equal to b. Sine theta is equal to b. So a square minus b square is just a plus b times a minus b. We can use this algebraic identity to simplify this, and we get cosine theta plus sine theta times cos theta minus sine theta over cosine theta minus sine theta. So obviously we can just see that these two parts are equal, this part and this part, so they just cancel out, and we're left with cosine theta plus sine theta. And if we look back at the original question, we were just asked to prove that this is equivalent to sine theta plus cosine theta, which we have done because we have found that the left hand side is equivalent to the right hand side. So that would be it for this question. So thank you guys for watching. Hope you learned something new from this video. In the next video, we will tackle this question about inversely variation and direct variation. And that's it for today. Thank you.